Hello everyone, in this video we will talk about simple pendulum. Let's first draw a simple pendulum. Suppose we have a string of length L which is light and inextensible. We can take a string or a massless rod of length L. Suppose this is a string or massless rod of length L. One end of this string or rod is attached to a fixed point O, and to other end a heavy particle of mass m is attached. So let we oscillate this particle which is attached to other end of the string. Let this particle be of mass m and its weight mg is vertically downward. Assume initially the string is like this. There is no motion, no movement in the string, and let A be the lowest position of the particle which is attached to other end of the string. And when this string or massless rod oscillates in a vertical circle, then the system is called simple pendulum. Like a child sitting on a swing exhibits the example of a simple pendulum, or a clock in which you can see a pendulum. That pendulum oscillates in a vertical circle like this. Suppose initially pendulum is like this in a straight line, vertical line, and at any time p, suppose particle is here and theta is the angle or angular displacement in a vertical plane of the particle. Here T is the tension which is applied by the string or rod in the direction PO. Alright, so let's see what kind of motion is exhibited by a simple pendulum. For that, we label the point to which the one end of the string is attached and fixed by O. Let O be the fixed point and L be the natural length of the string, and P is the position of the particle which is attached to other end of the string at any time t, such that angle AOP is theta. Here theta is in radians, and here theta indicates the small angular displacement. In a vertical plane. Now forces acting on the particle are its weight, which is acting vertically downward because of gravity, tension T in the string in the direction PO, now equation of motion of the particle. Let's see. We break the components of this weight mg in two directions. one component is in this direction, this angle will be theta because of alternate angle, and the component of this force T in this direction, this force mg in this direction will be first let's draw the angles. This angle is theta because of alternate angle, and this angle is also theta because of vertically opposite angle. So if we break this weight in the two components, one is in this direction which can be regarded as x component and it will be mg cos theta, and other component in this direction which can be regarded as the y component. So this is mg sin theta. So we break the weight mg in two components, or we can draw a tangent also to a vertical circle at P, and one component we break in this direction and another component in this direction. So this component which is along tangent, so equation of motion of the particle along tangent to the circle at P is ml d square theta by dt square equal to minus mg sin theta. How I have written this equation? Because this tangent is to the circle, vertical circle at P, and the radius of this vertical circle is L because the length of the string is L. So acceleration along tangent to the circle of radius L is L d square theta by dt square, and we know that by Newton's second law of motion, mass into acceleration is equal to the force. Now this negative sign is because that the acceleration of the particle is towards the mean position. Particle starts from here, at any time it reaches at B, it oscillates in a vertical circle. Suppose these are the two extreme points to which the particle can go. Okay, so particle starts oscillating between these 2 points B and B dash. A force always accelerates the particle towards A, that is towards mean position. So the restoring force is in this direction and particle is moving in this direction. So that's why we have taken negative sign over here, and this is equation of Newton's second law of gravitational forces shows that mass into acceleration is equal to effective force. So L into d square theta by dt square is equal to minus g sin theta. Here theta is very small angular displacement. So in case theta is small, sin theta is approximately equal to theta always. So we will have d square theta upon dt square is equal to minus g over L into theta, and if I compare it with this equation, d square x over dt square is equal to minus mu into x, which is the case of simple harmonic motion, we get that motion of simple pendulum is simple harmonic motion. Motion of simple pendulum is simple harmonic motion, and the time period of one oscillation is 2 pi over under root of this g over L, which is equal to 2 pi into under root L over under root G.